Look at the schematics for the turret rotation here.
Right.
It's incredibly complex for the era.
The power requirements alone must have...
The reactor shielding alone weighed more than a standard Sherman tank.
Okay.
That's why the propulsion system needed this radical new design.
The reactor's safety in the field cannot be guaranteed. The risk is too high.
But the tactical advantage outweighs the danger, sir.
The primary issue remains the heat exchange rate at maximum output. We could modify the coolant intake valve, but it risks overloading the secondary system.
The stress tolerances at this junction are too low. It's a critical failure point.
Yes.
We must reroute the primary coolant pipe to mitigate the risk.
The thermal stress on the moderator block is too high.
It'll melt down in the first 100 hours.
We must redesign the coolant pipes here.
This section of the cooling system is unstable under pressure.
Reroute the secondary pipes here, it might compensate.
Make the adjustment.
Running the numbers for the schematic change now.
Integrating the reactor housing with the propulsion linkage is proving difficult.
We need to adjust the mounting brackets, or we'll compromise the shielding.
This connection point is unstable. The thermal stress will compromise the seal. Agreed. We need to revise the coupling mechanism before we proceed with the prototype build.
Look here. The stress fractures on the primary manifold will be catastrophic at full power.
We need to reinforce the coupling assembly, but
Structural integrity around the core housing is our primary concern. All right, let's get the steam generator prepped for decoupling. Move the heavy wrenches into position.
Wires disconnected, applying the K-label now.
Good. This coupling is loose, ready to lift it out.
Valve mechanism is clear,
Setting it on the bench.
This valve connection seems slightly off spec. Refer to diagram 7 alpha.
Adjusting the torque now. It should align perfectly.
Carefully detach the coolant pipe. Securing the moderator rods now. Make sure it's labeled Alpha 7.
Pressure sensors on the starboard tread show an anomaly during the resonance test.
Agreed. We need to recalibrate the sensor array and rerun the sequence. Torque settings confirmed on the primary coupling.
Initiating alignment sequence now. Monitor the resonance stabilizers.
Reactor levels are stable. Initiating safety sequence check B.
Confirming sequence B activation. All parameters look nominal.
Propulsion systems are green. Reactor output nominal. Begin tracking maneuver. Confirmed. Proceeding with caution. All primary indicators green. We are clear to proceed with the power increase.
Wait, verifying the scram circuit first. Safety check not yet complete.
We're showing a slight variance in the flow rate here.
Adjusting the valve now. Check the pressure again.
Reading stabilizing. Looks good.
Adjusting the moderator rods now. Watch the neutron flux. Levels are rising slowly, holding steady at point 2.
Bringing the flux stabilizer online now. Levels are holding steady.
Readings confirmed. We have achieved criticality. The reactor is green. Initiating primary coolant pump override sequence.
Switch is engaged. Pressure holding steady at 200 psi.
Panel indicators are green. Reactor stabilizing.
Fluctuation on sector gamma 9, slight increase in neutron flux.
This weld looks compromised. Are you getting a good reading?
Negative. It's failing the ultrasonic test. We'll have to decommission the core until this is reinforced.
Final checks complete on the core. All right, team, let's get this mounted before... 800. Move it.
Secure the final harness.
Straps tensioned and locked. Confirm.
Transport manifest verified. Ready for deployment.
Watch the clearance on the starboard side. Holding steady. Tensioning straps now. Confirmed secure. Proceed with final checks. Tensioning tools engaged on harness 4.
Harnesses show proper tension. Confirming reactor seating.
Loading complete. The asset is secure.
Confirmed. We are ready for deployment. Components locked down.
Initiating reactor calibration sequence now. Power levels checking nominal.
All personnel, clear the exclusion zone immediately.
Reactor power levels approaching critical mass.
Firing sequence engaged. We have ignition.
Power levels holding steady. Chronometer engaged.
Recoil stabilized. Reactor integrity nominal.
Firing sequence initiated. Stand by for discharge.
Firing. Mark.
Recoil looks nominal. Reactor stable.
Secure the primary conduit line to the reactor housing.
Connections are made. Starting the diagnostic sequence.
The resonance readings are stable. Sealant looks good.
Confirmed. Adjusting the primary conduit connection now. We should be ready for the output test.
Check the primary coolant intake seal again.
Seal is holding steady. Pressure looks good.
Make sure the inflow valve is secure before we initialize the coolant flush.
Copy that. Securing the valve now. All right, initiating the cooling sequence now.
Pressure stabilizing at nominal levels. This forgotten prototype's nuclear design was revolutionary, shaping the future of military technology despite never seeing production.
The atomic tank prototype's revolutionary design may have been ahead of its time, but its influence on modern military technology is undeniable.
Charge. The key feature here is the innovative nuclear-powered propulsion system. This design fundamentally influenced the apprentice interest.
The prototype's nuclear propulsion system was truly revolutionary for its time.
Initial scans confirm
The reactor core's cooling system utilized liquid metal.
We're showing elevated heat signatures right here on the secondary coolant loop.
Look at the microfracturing on this weld point. Yep.
Is that within the original spec tolerance?
It is, but barely. We should annotate it for review.
Right there, that's where the microfracture is initiating.
I'm getting a high neutron flux reading in that exact spot.
Torque rod assembly 7 to specification.
Confirmed. Moving to Sector 8.
Reactor core connection stable. Moving to auxiliary power coupling.
Copy that. Monitor levels closely.
All conduits are secure. The reactor interface should show a green 2U stabilization reading now.
Yep. They're holding steady for now.
All systems nominal.
Power flow is stable. I agree. The core is ready for the next phase of testing.
Aligning the fuel rods now.
Confirmed. Core stabilization at 50% capacity.
Maintain alignment tolerances.
Check the alignment on rods 3 and 4.
Alignment confirmed, within specification.
Readings look good, ready for the activation sequence.
Core diagnostics stable.
Control rods fully seated and aligned.
Inspection complete. Ready for integration.
Check alignment on Sector Gamma. Ensure the rods are seated.
Alignment confirmed.
Locking mechanism engaged. Ready for transport. Approaching integration point. Watch clearance on starboard side.
Holding steady. Clearance is good.
Confirmed seated.
Guide the assembly into the core housing, slowly. Confirmed. Watching the alignment pins now. They're engaged. Locking sequence initiated. Secure.
Recalibrating the neutron flux detectors. How are the coolant levels looking?
Stabilization is holding steady. We are within nominal parameters.
Fuel rod assembly looks good, but neutron flux is fluctuating.
Adjusting the moderator input now.
Pressure gauges are holding steady. Looks good.
Recirculation valve aligned. Ready for the test, Charlie.
Flipping the primary interlock now. Green light confirmed. Pressure looks stable on the primary coolant loop.
Confirmed. Recirculation flow is nominal.
Pass me the long-handled torque wrench.
The readings on the starboard reactor housing are fluctuating slightly.
Systems check complete. Initiating power sequence now.
We have ignition. The prototype is live.